So I did all the, yeah, it's just started.
Okay.
So I did all the extension problems, but
Uh-huh.
I don't think we have to submit those. I think we just have to talk about them.
Yeah, we don't have to
Yeah.
submit it. We just have to talk about it. We have to like say the answers and make sure that everybody understands.
Mhm.
Okay. Then what were the answers? I have, for the first one, I have negative 0.8660. Is that
Oh, I
what you
still have it
have?
in the radical form.
Oh, I don't have
Um,
radical form.
Let me see.
Do I have to?
So on that chart I sent you,
Mhm.
on that circle chart, I think it has the answer. Let me see really quick. 4 pi.
Feinstein.
Yeah, so 4 pi over 3. I think the answer is supposed to be negative square root of 3 over 2. Is that what you got, Esther? Or what did you get for that?
Yeah, yeah, that's what I. Huh?
Which one? Negative square root of 3 over 2?
For number 1?
Yes.
For the.
Yeah, we're just.
Okay.
So do you see on the
Just
chart
the first
there?
extension problem.
Yeah.
Do you know how to find that?
Yes.
Okay.
Well, I don't know how
Sure.
to find the, like, I have the decimal. I don't have it in radical.
So on that chart I sent you, if
Mhm.
you just go and you look, it's in like the bottom left corner.
Oh, I know how to find it in the chart. Like, I can see what, like, I just don't know how to fill all that. Does that make sense?
Yeah, I just looked up online to fill up the chart,
Okay.
honestly.
Because I look it up and I see all the answers too, but I just don't know how they come up with the answers. I guess, do we just have to have it memorized? That's just what it is, and you don't have to like really know how to do it?
Yeah, so I was wondering about that also. Jared, do you know how to how to go through
So basically
problems and find
how
that?
I understood it is
Okay.
that so each one of those lines divides the circle into a certain amount. And so if you look at the top where it's like the 90 degrees,
Mm-hmm.
that is half of, let me see, how did I do that? That is half of pi, because pi is 180 on this chart.
Okay. Right.
And so on the left, you're going to have pi, and at the top, you're going to have pi half, like divided by 2.
Yeah. Okay, I see
I don't know
that.
if that, like, it makes sense to me, and I got the right answers like that.
Yeah.
So, for example, if you look at like on that chart, where it says pi divided by 3 in like the top right corner,
Pi divided by,
that means that is one of that chart. So just there's that section, this section, and then the next section. It would, since it's pi over 3, it means it's 1/3 of that entire 180. Does that make any sense at all?
So like a third of, like 1/3 of pi, or just no, it can't be.
Because on the other side, you see how on all the way on the left, like pointing to the left side, it's just pi.
Yeah.
At the top, it's pi divided by 2.
Yeah.
So it's half of pi. And then the pi divided by 3 is like pi third.
And then you have pi fourth.
Okay. Then... Yeah. Yeah, I got that.
So each one of those is like a fourth of that section. So if it says something crazy like 7 pi 6,
much more sense.
It just means divide the top part into 6, and then you have 7/6 of that. I don't know if that makes any sense. That's how I view it.
Okay, much more sense. Okay.
I don't know if I'm making any sense. I'm sorry.
Made more sense to me.
Okay.
Yeah, so that's helpful. Thank you.
The top part into 6 and then count over that many, like, since it's 7/6, you count over 7.
How do you
Yeah.
count the ones on the bottom though? Because I get like the P is the 180, but after that it goes more than 180. So
I'm not exactly sure.
okay, that's okay. Guess I can figure
So
it out
it
another
makes sense in
time.
my mind, but I'm not a great teacher. I can explain it.
Yeah.
But
Well, maybe we can go through the extension problems and just see,
maybe that'll help.
because some of these are on the upper division of the
No,
circle.
well, I mean, with the chart I can find it. So
But
they're
some of
all
these
in the
things aren't
circle.
on the chart.
Yeah.
They're not? Shoot.
Like
Like
cos 19
number
pi over
2.
6.
Yeah, 19 pi over 6.
7 pi over 4.
So what I did is I would check it too. I was checking it with the just typing it into a calculator just to make sure I was doing it right. But so you would divide that top half of the circle into, since it says 19 pi 6, you would divide it into 6 parts. And so the first part of that would be like at that 30-degree angle. The next one would be at 60. The next one would be at 90. So each one of those would be a sixth. And so what you're going to do is you're just going to count over. If it was 1/6, you would count over just to the 30-degree line. If it was 2/6, you'd count over to the 60-degree line. But since it's 19, it goes around a few
And
times.
you keep going around.
Yeah, you just keep going increments. So that one's 19/6. Does that make any more sense?
19.
So,
Okay, so I've got, that makes a lot more sense. So I've got it at the 210 degrees is where I ended up. So that would be 7 pi over 6. Is that?
It'd be the same. It'd be the same as 7 pi over 6.
So I got the degree for that one is 570. That's the degree.
For
so
that,
I answered the question just by converting those things to a degree and then just put it on the calculator. Does that make sense? So I have the degrees in the, like what they are in the circle.
that makes sense. I think I was actually doing that first.
Yeah, I have like all the degrees, so we can find it on the kind of on the circle, like, but I just don't have it on a radical form. That's the only thing. I have the answer for all of them, but not in a radical form.
So you said for number 8, you got, what was the degrees for that?
570. So that means it goes around the circle, keeps going, almost 2 full circles.
Yeah, so for number 8, I got negative square root of 3 over 2.
Okay.
Just because there's that rule that says the y-coordinate of a point on the equal represents the output function. Oh, wait, no. And we need the x-coordinate rule. It's the x-coordinate of a point on the unit circle represents the output of the cosine function at a given angle. And so you would go to that 700. I got 210 degrees, or 7 pi 6. And then you would look at the x-coordinate for that, and it's negative square root of 3 over 2.
For the,
I might be wrong, but that's for number 8.
For number 8, yeah.
Yeah.
And they want it in an xy coordinate as the answer?
No, because we're just looking at it right now, isn't it?
We're looking at what?
And it's cos. It just asks for cos. It doesn't ask for sin.
So would that mean we're just looking at the
It's value.
x coordinate, which would be the
The
7
negative,
pi over 6, or
or the x coordinate is the negative square root of 3 over 2.
Divided by 2.
Yeah.
Yeah, you're right.
And then for the sign, it's
Right.
let's try one more of those. What did you get for number 5?
That was 60 degrees. And so it is 1 over 2.
Yep. Yeah.
Okay.
I see what you're doing though. You converted it. Did you use like the conversion formula to change it to
Yeah,
degrees? And then
I
you
use
found
the
it?
conversion formula to change it to degrees.
Okay, that makes sense.
That just
Because I think I did that for the first two, and then I stopped.
Yeah.
Yeah.
Okay.
And like, this is how I always have to be, because I mean, I can memorize it real fast, but I'm pretty sure those lines are gonna change, right? Or this is how it usually is.
The lines will always be this same. I
It
think
will
that's what
always
makes
be at
it.
30
Yeah, they'll always
degrees,
be the
40
same.
degrees, 60.
Well, we
maybe.
might have something else, but if it's at 30 degrees, then the sign will always be. What was it? The sign will always be the y coordinate.
Yeah.
Yeah.
And so I think these are just
And
the
the
most
x will
common.
always be the cos.
I guess these are the most common, yeah.
Yeah, 30, 60, 45. These are the most
Okay.
common angles. So
Because if
there's
it's like
probably
that,
going to get more complicated as we go along, but
probably.
Yeah, but just the angles of the circle are good to know, I think.
Mhm.
Awesome. Well,
Cool.
I think we all kind of figured out how to find it using the circle.
Yeah. I think I understand it a lot better, at least.
Yeah.
Okay.
Oh.
And then we need to answer the following questions as a team. We need to find sim of p over 3 and cos of p over 3, which is...
Wait, where is that?
What?
So I'm reading the instructions for the Google Hangout on air.
I'm
Are you
looking at that. Are you under team discussion
Instructions.
or
I'm in number
extension
2,
prop?
extension problems.
Oh, okay.
Oh, where it says the fundamental theorem of trigonometry.
Yes.
Okay.
Okay, I got that.
Got it.
I wrote those down.
Got it.
So did you find this square? I'm sorry. Did you find the sine and cosine of all those examples in squares?
I didn't.
Of all the examples where?
Under number 2.
Oh. Of those two.
Where it says find the sine of pi over 3 and cosine over pi over 3.
I haven't.
Okay, I found them. It's so sine of pi over 3 is a over 2. And if you square that, you get 3/4. And then cosine pi over 3 equals 1/2. And if you square that, you get 1/4. And so with all of those examples, the thing that I noticed is that the sine and cosine always add up to 1. If you square the answer that you get for cosine and sine, it's always going to be 1. Or if you add them together after that, it's always going to be 1.
Okay. And is that the same with, let's see, pi over 4 and pi over 6?
Mm-hmm.
Huh.
The sine of that is square root of 2 over 2, and the cosine is square root of 2 over 2. And if you square those, then you get 2/4 and 2/4, so it adds up to 1.
To 1, yeah.
And the same thing with the last one.
Okay. So do you always have to square it for it to be equal to 1, right?
I don't know what the...
Because like the theorema, whatever, hate English. The fundamental theorem of trigonometry, it has that x to the 2 power plus y to the 2 equals to 1. Which is what you just did.
Basically, yeah.
Yeah.
So I'm not sure what how you implement this in practice or what it's used for, but I know that it'll always equal 1.
Yeah, that was the correlation.
Yeah. Maybe it's just like a way to check yourself or something. I don't know.
Yeah. Which is it's interesting. The first example was like they were the same, pi over 3. But the second example was pi over 4 and pi over 6, but we still got 1, which makes me think,
oh,
are you going to get...
So it's So I did the sine of pi over 4 and the cosine of pi over 4.
Okay.
And then I did it with sine of pi over 6 and cosine over.
Okay, that made much more sense.
Yeah.
I thought you were comparing pi over 4 and pi over 6.
No, I did the cosine and sine of both of those.
Okay, got it.
So he repeated, the first 2 steps with those numbers instead of p over 3. And they're always equal to 1, right? That's what we said?
Yeah, so the pi over, well, so far, pi over any number, the sine and the cosine, the sum of sine and cosine will be 1.
Yeah, you have to square it first and then add it. And then it will be 1.
Right, squared and then, yeah, added.
Okay.
Cool.
Yep.
Okay, and then it says that we need to discuss the motion of a spring and go through the practice problem.
Yeah, I didn't look at that. I must have missed that one.
The PowerPoint. Did
Number 4.
Maria, did you look at the PowerPoint?
I look at the PowerPoint. Wasn't that helpful? But...
Oh, I didn't.
Yeah, it just finds the theorem of trigonometry, like what we just were talking about. Like if you square it and then you add it, it's gonna be equal to 1.
Yeah, that's basically what it is. It says like x2 or x squared plus y squared equals 1.
Yeah.
Yeah.
That's what it says. Like that's what the PowerPoint is saying. Now,
okay.
With the book.
Please note that the square is written in between and at the end. The first one squares the value of cos, which is x, and then the second one squares the value of x, and then applies it to cos. Okay. So that's pretty much what we just talked about.
Mm-hmm.
Mm-hmm.
Okay.
Okay. So you all
Alright,
trying to
so-
find the chapter. We're in chapter 5, right?
I think so.
Your book corresponding to week 3. Yeah. And yeah, okay.
Formula for the motion of a spring. I must have missed that part.
Yeah. Can you guys, I've been trying to figure out where you access the ebook because I got onto it once and then I haven't been able to find it again. How are you accessing the book?
Let me see where I
Just go to table of content in iLearn and just scroll down, and in the first part it's gonna say e-text.
Under content?
Table of content, yes.
Oh, table.
Well, if you go to the content tab and then you scroll down to table of contents.
The table of contents. Okay, let me click on it.
It should say like announcement, assignment, study plan, gradebook, and then e-text.
Okay. Yeah. All right. We're golden. I found it.
Cool. I honestly haven't used it too much. I've just been using YouTube videos.
Yeah.
Things.
Yeah. I've been using MathLab.
Oh, nice. Is it the same textbook?
It should be.
The
textbook is in my MATLAB.
No, well, I meant like there's a math lot, like a physical math lab at the library that I've been going
okay.
to. Like on,
I see.
I'm not the online My Math Lab. Sorry, I forgot that was called the same thing.
I see.
Sorry. Okay, so I'm in the textbook now. We're going to.
Where is that?
5? Is that chapter 5, right?
Yes.
Okay.
So where does it say the motion of a spring? I must have missed that.
I don't know. It should be like page something, so we're in the hunt to like.
I know. If you guys found a search, we can search some keywords. Motion of spring.
Let's see.
Page 359 is what I'm getting when I search it.
359?
Mm-hmm.
Okay. Go to 59.
Which I'm not, do we need this formula for the quiz? Because I looked at the problems on the quiz and didn't really see
Here
anything.
it is. Okay. I think this is the last thing we have to do for like the transmitting live kind of thing. We just have to go through the problem and do the problem.
Oh, so for the group quiz, we don't have to record that?
So all of these is just for the hangout, the thing that you're gonna like the video. What are we doing right now? And then the quiz is another thing that we don't have to like.
We don't have to record it. Oh, that would make sense.
No.
That would make sense so that we couldn't like post it on YouTube and everyone else see all our answers.
I mean, it is
that
like
would make sense.
Yeah.
But we still do it as a group, right?
Yeah, it says like
Yeah.
it is a group, but we don't have to record it.
Okay.
Okay, so I can, whenever we're ready or whenever we finish talking about everything, I can go ahead and stop the broadcast.
Okay.
Yeah. Do we want to go through this motion of a spring thing, or do we want to?
Let's check that out.
Yeah,
really
we should
quick,
check it out because it's one of the steps.
Okay.
Because I haven't even looked at that yet.
Yeah, I haven't either. A weight on a spring is set in motion with an upward velocity of 3 centimeters per second from position 2 centimeters below equilibrium. Okay. Assume that for this spring and weight combination, the constant W has a value of 1. Write a formula that gives the location of the weight in centimeters as a function of the time in seconds, and find the location of the weight 2 seconds after the weight is set in motion. Whew. So it wants us to come up with
I have to read that again. Wow, this is Greek to me.
I mean, it gives the
I'm
solution in
pretty
the
sure I don't
pattern,
know
so
how to
are
do
we
this.
supposed to like talk about it?
Oh, we're supposed to try to figure out the formula, or are we just supposed to look at it? Because the solution's right there.
Oh,
the
yeah.
solution. Well, I guess there is like another problem on the bottom, so I guess we just go through it and we see how they do it, and then we try to find out the new problem that they give us. Does that make sense?
Yeah, because it says on here, discuss the formula for the motion of a spring and go through the practice problem. So
yeah. Okay.
I think you're right. Yeah.
Okay.
Okay, so velocity is negative. What does the W stands for? It's just a constant. Okay.
W is a
Mm-hmm.
yeah. Do you guys understand the V to the 0 power and X to the 0?
Yeah. So V is the
Okay, cool.
velocity. Is like how fast it is going, and because it's going upward, it's negative.
So it's
Which
0.
so if it was going downward, it would be positive.
So that's -3.
Yes.
And then what does X represent? X0?
It looks like it's like the position, like how inclinated it is or something like that.
2 centimeters below
No,
equilibrium. So
equilibrium.
since it's below it, it's negative.
No, it's below, so it says that it's positive.
Okay.
Oh yeah, below equilibrium is positive, yeah.
So I'm gonna say like equilibrium would be like if it was like in a straight line, and then it's like 2 centimeters downward kind of thing, and the string wants to go up. It's going up. Does that make sense? If you put it like on your mind.
That's starting to make sense.
Okay. And then the W is just a constant. So
if you look at the practice problem.
So if time is 2 seconds.
and we're looking for location of the weight. I have no idea what that is.
So it's sine of 2, or it's -3 sine of 2 plus 2 cosine of 2.
-2. Oh, T equals 3. Okay.
T equals 3 or T equals 2?
T is equal to 2. T is equal to the time. So it's 2 seconds.
Oh, and then it's asking the location.
Yeah, we're
T equals 3.
okay.
Are you okay, sorry. Are you looking at, are we onto the
Are Are we gonna try the problem now?
I was still looking at the example. I was just
Okay,
figuring
sorry.
out. Sorry
I
about
was
that.
no, it was.
I was just
like,
writing it out, trying to figure out why they got that.
No worries.
Okay. Yeah, I'm ready to go ahead and try the practice one.
Okay.
Is that under
So
the try this?
I think that's what that is.
Yeah.
I'm gonna guess that's what that is.
I just know.
If x equals -2 sine plus 2 cosine gives the location in centimeters of a weight on a spring represented by t seconds after it is set in motion, then what is the location at time t equals 3?
Six.
So would we just plug in 3 where t is located and then solve for x?
That's pretty much what I'm doing.
Yeah,
Okay.
that's what I started doing. That's, yeah.
Did you all get a number?
Yeah, I don't know if I did it right. I got 1.51900 blah blah blah.
I didn't get that. I got 2.774504.
Maybe I did it wrong.
I don't know
Yeah.
who did it wrong. That's the thing.
What did you get, Esther?
I haven't been able to solve it yet.
So how did you
Okay.
did it?
How did I do it? I just plugged it into here.
You just plugged it into a calculator?
Yeah, I was just trying to see if I got it. But
Yeah,
Did you make
I don't know
probably
if
a
I
good idea.
typed it in right.
Okay.
Let me do each step by itself and make sure it's not like doing anything out of order.
Where do we check the answer for this thing? We don't know.
I don't know if they have it.
Yeah, probably don't have it. Let's see. This is
Oh.
example 8.
Okay, I don't think I did this right. Let me try it on a different calculator.
Maria, what did you get?
I got 2.774504. Do you
So I just did it again a different way, and I got like 3.4393.
Okay, how are you doing it?
Well, I just typed in sine of 6 on my calculator, and then found that, and then times it by -2.
Yeah, and that would give you negative 0.209056.
Say that one more time.
Did that whole thing give you 0.209?
No, it gave me 0.558830.
Why did yours?
Sine of 6.
Times 2.
Negative 2.
I keep getting the 209.
Keep getting negative 0.55 stuff.
Is our calculator are just like messing up. Let me see. I'm gonna like Google it then.
Yeah, that might be a good idea.
I'm doing it on my phone because my roommate got my calculator for an exam, so maybe that's it.
Oh,
Let's see. Same of, because it should be the same thing. 6.
that doesn't make any sense.
Huh. Yeah, my phone doesn't know how to do this right because Google gave me another number.
What did it give you?
But it will be a positive number. Wait. Times
Yeah, I got a positive number.
2. Okay, did you get 0.558?
Yeah, that's what I got.
So I cannot trust my phone. Okay. This is ridiculous. Huh.
And
Okay.
then I did.
So
Oh,
maybe
wait, was I
you got it
doing...
right and I get it wrong then.
Wait, let me try something really quick just to make sure I'm doing it. 6.
Because of 6.
Yeah, I'm getting 3.439.
2.8805. Yeah, I think that's right. Almost there. Plus.
Okay. I just got back on, guys. It kicked me off. Did you figure it out?
Okay, do you got 3.438?
Yeah, that's what I got.
Okay.
Say that again. 3 point what?
438.
Yeah, 3.43. I'm getting
88.
3.439, but
Yeah, 3.
Yeah,
438.
I think mine rounded up as well. 3 point.
okay.
I
I mean,
don't.
it continues. I have a lot of decimal points, but
Yeah. Okay.
okay.
So that's
Cool.
whatever that is. Like I
I
can
don't know
make
what
the
that has to
program,
do with
but yeah.
but
I think like isn't that kind of like the diorama, like the problem, the theorem of trigonometry kind of thing? Well, not
is that
really,
what
but
that is?
Oh, what we just did?
well, I mean,
You're
you have
saying?
the sin plus cos, so it's kind of similar, but you don't square it,
Maybe.
and it didn't give you 1, so.
Yeah, maybe.
I don't know.
Do you all realize that there is a W and it's not in the equation?
Yeah, I didn't know what that was for.
Yeah,
It's just an extra part or something.
I don't know. Yeah. You're saying the
Or maybe since it's equal to like equal to 1, they just didn't even put it in there because like something times 1 is just going to be itself. But I don't know. You think they're? I don't know. I don't know.
I don't know either.
Well, we got it.
All right. So do you want to? Yep.
Yeah.
We want to go ahead and stop the broadcast and look at the quiz.
Yeah, why
Let's
don't we
do
do that?
Okay.